Okay, so this video is about there are 4 questions in this video, and all of them are on real polynomials, and we'll be finding unknown coefficients as well as unknown factors. Some of the questions might be tricky as well, so let's look at the let's start on question number 7. Looks fairly straightforward. So what we do here is we're given 2 polynomials here. We're given 2 quadratic factors of a quartic polynomial, and each of these quadratic factors have one unknown coefficient as indicated by P and Q, and we need to find the values of these variables P and Q. Okay, so what we do is first we multiply these quadratic factors so that we get a quartic factor. And how to multiply? Let's do that. We can do that on fly. So first term is x4, and after that I'm looking at x cubed. So how do I get x cubed terms? It's very easy if you follow a system. What I do is I follow a system. I see that I'll get a x cubed if I multiply this with this, and then I move inward and I get these 2 terms. So first x cubed term that I will get would be from x4 and x square and qx here. So I'll get a q here. The other one will be p, and that's my x cubed. We'll follow the same strategy when we are trying to find the coefficient of x square. So again, x square, we pick up the outermost pair, and then we move inward. So x square you will get from here, that's first term, then that's the second term, and that's the third term. Yeah, so we need to go one by one. So first term is I get 5 and x square, so I get a 5 here. Next one is pq, and next one is -2. Okay, likewise I go with a x term. So how do I get x? I get an x from here, one term from here, and one term from here. So what I get is 5p minus 2qx, and then I just left with the constant term, which is -5 and 5 and -2, which is equals to -10, and that gives me this equality. Basically, you got 2 quartic polynomials which are equal. And just remember that whenever two polynomials are equal, then the coefficients of like terms are same on both the sides. What it means is that the coefficient of x4 here should be equal to the coefficient of x4, and likewise for x cubed, x square, x and constant term as well. So we equate coefficient of x cubed first. So coefficient of x cubed, what we get here is p plus q on the left hand side, and on the right hand side I get a 1 here. I'll divide it into 2 parts so that I have equation there. That's equation number 1. Then I equate coefficient of x square. On the left hand side I got 5 minus 2, so I'll write that as 3 plus pq, and on the right hand side again it is equals to 1. That's my equation number 2. And then I look at the coefficient of x as well, which gives you 5 minus 2q on the left hand side, and on the right I got 9. Very easy. You got 3 equations, you got only 2 polynomials. I will work on polynomials number 1 and equation number 1 and 3, because equation number 2 got a pq term which might not be so convenient for solving. So I can solve equation number 1 and 3. I'm not going to solve it. I can do that using a graphing calculator as well. So solving, we get p is equals to -1 and q is equals to 2, and this is your answer. Now you can check whether these values are correct or not, and you can do that using equation number 2. So I'll check that as well. Check in equation number 2. I get 3 plus -1 times 2 equals to 1. 3 minus 2 equals to 1 equals to 1. So it basically checks out. So this is my answer, and that's your question number 7. Next one, let's look at next problem, which might be a little bit tricky. So here you got a polynomial. It's a cubic polynomial, and the only clue, it has got one constant term which is not known, as indicated by letter P. Only clue that is given is that it has got two linear factors. So there are two linear factors. It means if I have x minus a as one factor, then there will be one more of that. So I can write my polynomial as x cubed plus x squared minus 5x plus p. And because I got two linear factors, so I'll say that is my two linear factors. And then I need one more linear factor to make it a cubic polynomial. So this is what it got. I can multiply these terms on the right hand, these factors on the right hand side. X squared minus 2ax plus a squared x plus b, and then again I multiply them. So first term is x cubed, then I need to, how do I get x squared? I get x squared by taking these two and these two. So I'll clean that up, it is that, so that I have room there. So I'll get x squared term, first will be b, and then this and that will give me minus 2a, and that's my x squared term. Then I'm left with x term. So how do I get x? I get x using two different pairs, one from here and one from here. So first is I get minus 2ab, and the next one is a square. That's my x term, and plus my constant term is a square b. All right, so just like in the previous question, you got two polynomials which are equal, which means that the coefficients of similar terms on both sides should be equal. So I'll equate coefficient of, it's a bit messy, so let me clean it up. Coefficient of, first I'll start with x squared. So x squared gives me, let me divide it into two parts. Coefficient of x squared on both the sides. So I got b minus 2a on the right hand side, and that should be equals to 1, which I can write as b equals to 1 plus 2a. This is my equation number 1. Then equate coefficient of x. So coefficient of x is minus 2ab plus a squared is equals to minus 5. That's my equation number 2. And constant terms gives me that a square b is equals to p. I don't need equation number 3. I need to solve 1 and 2, because equation number 3 you got all the variables, all the unknowns there. Equation number 3 will be useful for finding the value of the p once you find the values of a and b. So you got equation number 1 and 2, two variables and two equations. We should be able to solve it. So what I'm going to do is I'm going to substitute the value of b from equation number 1 into equation number 2. So substituting value of b, what I get is minus 2a 1 plus 2a plus a square is equals to minus 5. That gives you minus 2a minus 4a square plus a square is equals to minus 5. That gives you a quadratic equation, 3a square plus 2a minus 5 equals to 0. Now we can factorize it. We can use this a quadratic equation in A, and we could use the quadratic formula to solve it, but it would be easier to factorize them because I can clearly see that they can be factorized. So how do you factorize them? You got 3 and minus 5 here, so 3 times 5 is minus 15. Now we need two factors of minus 15, which when added gives you plus 2. So it's very easy. You got 5 times minus 3. So when you multiply, you get minus 15, you add them, you get plus 2. So I'm going to split this 2a in the middle as, I'll write that as sum of 5 and minus 3. So I hope all of you are familiar with this. 5a minus 3a minus 5 equals to 0. That gives you, okay, sorry. So take a out, 3a plus 5. You take minus 1 out, 3a plus 5 equals to 0. Let's scroll it a little bit more. And that gives you a minus 1 and 3a plus 5 equal to 0, which gives you two values of a equals to 1 and a equals to minus 5 or 3. Now we got this for each of these values. Now we need to find the value of b. So we'll just use the equation number 1 here. So a equals to 1 gives you b equals to 1 plus 2 times 1, which is equals to 3. And a is equals to minus 5 over 3 gives you b equals to 1 plus 2 times minus 5 over 3, which gives you minus 7 over 3. So far so good. We found the values of a and b, but we want to find the value of p, and equation 3 gives us the value of p, and we can see that because there are two different values of a and b, we will have two different values of p as well. So therefore, from equation number 3, p is equals to, we are going to take the first set of values. So a square b, so a square times b, that gives you 3, and p is equals to, again, a square b, so a square is minus 5 upon 3 square minus 7 over 3, which basically gives you minus 175 or 27. So these are the two values of p which would give you, when you substitute in your original cubic polynomial, you will have two identical linear pairs, and it's easy to check. So what you can do is you put this value of p here in this polynomial and put in your graphing calculator and plot it, and you will be able to see that in both the cases it is touching the x-axis, because two identical linear factor means your polynomial should touch your x-axis. Okay, let's move on to the next question. Factorize. It should be an easy question, but you can see that you cannot easily factorize. And why not? Because you can see that if you try to find its discriminant, you will find that discriminant is negative. So what we do is, we trying to convert that polynomial into an equation and then try to find its roots. So what we do is, so we have an equation, we convert this into equation by making it equals to equals to 0. So now we can find its roots. We are all familiar. So minus b plus minus, just for the sake of it, I'll just write the quadratic formula there. So here I get minus 4 plus minus square root of 4 square minus 4 times 1 times 5 divided by 2 times 1. So that gives you minus 4 plus minus 16 minus 20 upon 2, which gives you minus 4 plus minus minus 4 divided by 2, again, which gives you minus 4 plus minus 2 iota divided by 2, which gives you minus 2 plus minus 2 iota. So these are you got two roots there, and because these are the roots of the equation, so your equation, original equation that we have here, it could be written as a product of two factors. All right, so therefore x squared plus 4x plus 5 equals to 0 becomes x minus 2 plus 2 iota, x minus 2 minus 2 iota equal to 0, and that implies that your x squared plus 4x plus 4x plus 5 can be written as these two factors. Let me clear that up right properly. X minus 2 plus, oh, did I make a mistake? Yes, I did not. This is not 2 here, there should be only 1. There should be an iota only. Okay, that, and here as well I need to correct that. Minus 2 plus iota, minus 2 minus iota. So minus 2 plus iota, x minus 2 minus iota, and that is the required factorization. All right, let's look at question number 10, which if you look at it could be a little bit tricky. So let's take a look. You're given a quartic polynomial, and it says two factors are given, and you need to find two other factors. And the quartic polynomial has got two unknowns there, as indicated by a p and a q here. So the steps are almost same, but we'll need to do a little bit of thinking here. So let's write it like this. You got 3x4 plus px cubed plus qx squared minus 9x minus 10. Okay, but you got two factors are already given, so I'll write them like this: x minus 1. Now you got two factors. It also means that you should have another quadratic factors here, right? So I could have a quadratic factor like ax squared plus bx plus c. Now you got so many variables, so many unknowns there. A, b, and c are all unknown, and p and q are also unknown. But here, if we are careful and we compare the two sides, we are able to get rid of a few variables here. So let us look at the coefficient of x4. So if you get x4, how would you get x4 on the right hand side? You would get x to the power 4 when you multiplying this, but you multiply 3x with x and then with ax squared. So x4 term that you get here will be 3ax to the power 4, and on the left we see that it's only 3x4, so a has to be equals to 1. So we got rid of a here. Likewise, if you look at the constant term on the left hand side is minus 10. How would you get a constant term on the right hand side? On the right hand side you get constant term and you multiply minus 1, this minus 1 plus 2 and c, so they give you minus 2c, and on the right hand side it is minus 10. When you compare minus 2c with minus 10, you can see that c is equals to 5. Okay, so we got two values. We can, instead of writing a and c and then finding their value, right in the beginning here we can get rid of a and c and write their respective values. Okay, so I'll clean this thing up and write my quadratic factor again. Okay, so what we have is x squared. I'll keep that as bx minus 10, so I need a plus 5 here. That done, I have only one variable on the left hand side, on the right hand side, and two variables, two unknowns on the left hand side. The steps are same. We just multiply these things together. So when you multiply them, you get, I'll multiply these two factors first. I get 3x squared minus x minus 2, and this remain as, instead of writing that as b, I'll write it as ax. So x squared plus a doesn't change anything. So x squared plus ax plus 5. And then we can multiply. Again, we get an x cubed term when we work step by step. So we get x cubed term when we multiply here, and then we take one in a term. Right? So I'll clean them up. We use that strategy. Very useful, very handy. So 3x squared and ax, that gives me 3a. And then I get a minus 1. That's my x cubed term. Now x squared term, I'll get 3 of them. So first is, again, this first term and the last term here. So that gives me 3 times 5 is equals to 15. Then minus a minus 2. And that is my x squared term. X term, again, we get by starting here, that and that will give us x terms. So I'm just going to clean them up. So x term that I'll be getting is sorry, that gone there. X term will be minus 5 minus 2ax, and the constant term is minus 10. Now equating coefficients, so I first take coefficient of x cube. It's we'll need a lot of room here, so sorry, so it's gone up. Okay, I'll draw a line here so that we have more room here. So coefficient of x cube will give me 3a minus 1 is equals to p. Coefficient of x squared will give you, I'll write that as 15 minus 2 is 13, so I'll write 13 minus a is equals to q, and the last term is my constant term, and I get minus 5 minus 2a is equals to minus 9. Now we can see that the third equation straight away gives me value of a, so I'll solve it, and that will give me value of a is equals to 2. Now I'm left with equation number 1 and equation number 2. We don't have much to do here. From 1 I get p is equals to 3a minus 1, which is equals to 3a minus 1 is equals to 5, and from 2 I get q is equals to 13 minus a, which is equals to 13 minus 2 is equals to 11. And therefore the other, but we are trying to find the two other factors. The question says that you are given two factors and you need to find two other factors. So we need to find other two factors, and other two factors come from this quadratic that we have assumed here at the beginning. So other two factors will come from x squared plus ax plus 15, which basically becomes x squared plus 2x plus sorry, it's not 15, it's 5. Now again, we need to factorize it. We'll need to first convert that into equation and find the roots and then write them as factors. So corresponding equation is x squared 2x plus 5 equals to 0. The roots, x is equals to minus b plus minus square root b squared minus 4a times c divided by 2a, and that gives us minus 2 plus minus 16 divided by 2, minus 2 plus minus 4 iota divided by 2, which gives you minus 1 plus minus 2 iota. Therefore, our equation can be written as x squared plus 2x plus 5 can be written as product of these two factors which come out of these roots. So x minus 1 plus 2 iota and x minus 1 minus 2 iota, and these are the two required factors, and that's where we're going to stop.